Hey everyone, and welcome. Get ready, because today we are going on an incredible adventure to a secret city, a place where every single thing in the entire universe lives. Are you ready to explore? Let's do it.
I mean, have you ever really stopped and thought about it? What are the tiny, tiny little bits that make up everything? You know, like a soccer ball, or an apple, or even the air we're breathing right now. It's such a cool question.
Well, the answer to that huge question is actually hidden on a very special map. And nope, it's not a map to bury treasure, it's a map to something way cooler. Element City.
All right, welcome. Let's start our grand tour of this amazing city. You're about to see just how perfectly organized it is.
And here it is. This is our map. It's called the periodic table, and it's basically a big chart that neatly organizes every single ingredient or element that makes up our entire world. Can you believe there are 118 of them?
So just like in any city, every resident in Element City has its own little house with a special address. That's how we can find them and learn all about them. Okay, first thing you'll notice is the atomic number. This is the most important part of the address, for sure. Think of it like the element's house number. This number tells us exactly how many protons are inside, and that number is what makes every single element in the city totally unique.
Next up, you've got the atomic symbol. This is just a short 1 or 2 letter nickname for the element. It's kind of like putting the family name on the mailbox. H for hydrogen, O for oxygen. And a fun fact, some are based on old Latin names, which is why gold is Au from the word aurum. Pretty cool, right?
And finally, there's the atomic mass. This number tells us, more or less, how much the whole house weighs. It's the total weight of those protons we just talked about, plus their neutral partners, the neutrons. Together, they make up almost all of the atom's weight.
Okay, so now that we've checked out a single house, let's zoom out and explore the different neighborhoods in Element City. You can see it's super colorful, and guess what? Those colors tell us a lot about who lives where.
Over on the left side of the city, we have the metals neighborhood. These guys are usually shiny, bendy, and they're fantastic at conducting heat and electricity. You know, like a copper wire or an iron pan. Then, way over on the right side, we find the non-metals, and they're pretty much the opposite. They're often dull, can break easily, and they're not good conductors at all. Think about the oxygen we breathe or the carbon in your pencil.
And right smack in the middle, between those two big neighborhoods, are the metalloids. I like to think of them as the suburbs of our city. They're a little bit like metals and a little bit like nonmetals. The most famous one is silicon, which is what makes all of our computer chips work.
Our map is so smart, it can even tell us if an element is a solid, a liquid, or a gas at room temperature. The color of the symbol usually gives it away. On this chart, black means it's a solid, like iron. Blue means it's a gas, like oxygen, and green is for liquids, though there are only 2 of those.
But wait, Element City isn't just organized into neighborhoods. If we look even closer, we'll see that it's also organized by families. These are groups of elements that live right near each other and act in really similar ways.
So you see the columns that go up and down? Those are called groups. Let's imagine they're like tall apartment buildings. Everyone living in the same column is part of the same family, and they all behave in similar ways. And that's because they have the same number of electrons, those tiny particles that buzz around the outside, in their outermost layer.
Now, the rows that go across are called periods. You can think of these as the streets in our city. And what's amazing is, as you walk down a street from left to right, the elements change in very predictable ways. It's this beautiful, repeating pattern.
And hey, check this out. Look at what happens as you go down one of our apartment buildings, down a group. The elements actually get bigger. That's because each new row adds another layer of electrons, just like adding another floor to a building. How cool is that?
Wow, you've learned the whole layout of Element City. Great job. So I think it's your turn to be the explorer. Are you ready for a little fun?
Trying to memorize the whole table can feel like a lot, but we can use our imagination to make it super easy. Let's start with a silly little story for the first 2 elements.
Okay, get a picture in your head. For element number 1, hydrogen, I want you to picture a big red fire hydrant. You got it? Okay, now for element number 2, helium, imagine a giant helium balloon is tied to that hydrant, and it's so full of helium it's lifting that heavy hydrant right off the ground. Hydrant for hydrogen, helium balloon for helium. See? It works! All right, pop quiz time. Using what you've learned, can you find oxygen? Its nickname is O, it's on street number 2, that's period 2, And it's in apartment building number 16. That's group 16. So what's its special house number? What's its atomic number?
Yes, it's 8. Fantastic job, Explorer. The atomic number for oxygen is 8, which means it has 8 protons. You've got this.
Okay, one last challenge for you. Can you find the element sodium? Its symbol is Na. Once you find its house, look for the number at the bottom. What's its atomic mass? Did you find it? It's about 22.990. That's how much an average atom of sodium weighs. Awesome work!
You know, this quote says it all perfectly. The elements aren't just a random jumble of things. They're an organized, beautiful family. This map of Element City doesn't just explain chemistry. It helps us understand the building blocks of our whole universe.
And just like that, you are now an official Element City map reader. You have the guide, you know the language, and the entire world of chemistry is just waiting for you to explore it. So the only real question left is, where will your curiosity take you next?